Okay, so here is our last review problem that we're going to go over. You are down the shore and you see your lab partner standing on a hotel balcony 10 meters above the ground. You ask them to throw you a calculator so you can solve an immediate physics problem. They toss it up in the air with a velocity of 5 meters per second at a 20-degree angle and you catch it. What horizontal distance away from you are they? So, first thing I'm going to do, since I know I've got a two-dimensional problem here, I want to draw a picture of my situation. So here's my balcony, and there am I, some horizontal distance away. And I know that my balcony is 10 meters. The other thing that I know is that they're throwing this calculator at a 20-degree angle and with a speed of 5 meters per second. Since I have a speed at an angle, I know I have to resolve that into my x and my y components. I can't work with angles. I have to work with only x or y. So let's resolve that. So I'm going to picture this as a right triangle. There's my angle. There's my 5 meters per second. Here's my Vx. Here's my Vy. So Vx is going to be V cosine of my angle, or 5 cosine 20. Make sure your calculators are in degree mode. I'm going to hit that in. I already have, and I get 4.7 meters per second. I'm then going to find my Vy. Vy is going to be the sine function. Hit that into my calculator and I get 1.7. Now, before I go any further, I'm going to stop and ask myself if my answer makes sense. I have a very low angle, relatively low angle, 20 degrees, so that means my horizontal component, or my Vx, should be greater than my Vy, my vertical component, and indeed it is. So I know I did that step correctly. So this means that my calculator is going to be moving forward at 4.7 and up in the air initially at 1.7. My x direction, we remember, is constant, but my y direction is one of free fall. Okay, I'm going to keep that in mind as I do my next step. My next step involves finding time, because time, we remember, links both my x and my y direction. So I have to decide how I'm going to find time. If I had been given my x direction, if I had been given what this x was, finding time would be relatively easy. I could just say my velocity, my distance, I can get time from that. But since I don't know x, I have to use my vertical direction, which means I'm going to be using this equation. Delta y equals VIT plus 1/2 GT squared. And what is going to be obvious in a minute is that I'm going to have to use the quadratic in order to do that. So I'm going to plug in my variables. Usually I manipulate my equation, but since I'm going to have to use the quadratic, I'm going to just plug my variables in. That's going to give me -10 for my delta y, negative because my calculator is going to be dropping, equals my VI, which is positive 1.7, positive because it's initially rising, plus 1/2 negative 9.8 times t squared. And now I'm going to simplify this equation and put it in the form of the quadratic equation. So that means it's going to be 0 equals 1/2 times negative 9.8 is negative 4.9 t squared plus 1.7 t, and then since I brought the 10 over to the other side, it becomes positive. I'm now going to hit this into my calculator in my quadratic equation solver. Now, what if you don't have a quadratic equation solver? Well, you'll just use the quadratic equation, which I would give you on a formula sheet if you need it. So once I hit this into my calculator, I get two values. I get positive 1.61 seconds and negative 1.27 seconds. I know time can't be negative. Since time can't be negative, I'm going to cross that value out. It's impossible. So my time has got to be 1.61 seconds, meaning it's going to take 1.61 seconds for that calculator to go from your friend's hand to yours. Now that I know that time, I can find my distance, because the same time that it drops for is the time that it moves horizontally for. So I can say x equals Vx times t, where Vx is my horizontal velocity, 4.7 meters per second, times 1, pen doesn't want to write, there we go, 1.61 seconds. Put that into my calculator, and I get that I was standing, or you were standing, 7.57 meters from the edge of the building, or from where your friends were standing. Okay? Now, this is the most complex problem that we do in kinematics. The big thing to remember is horizontal moves with constant velocity. Vertical moves with acceleration due to gravity, free fall. The time, however, is the same for the vertical as it is for the horizontal. Okay? All right, these are the end of our review problems for our test. I know there are 2 other problems on the review sheet. They would not be a major problem that you would see. So you don't really have to focus too much on them. Okay? All right. Have a good day.